Good morning, grade 9 students, and today we will learn another new topic, and it's about current, voltage, and resistance. For our intention, competency, participate in guided investigations to infer the relationship among current, voltage, and resistance in assembled series and parallel circuits with varying numbers of loads and batteries. Think about it. Have you ever noticed that if you turn the faucet handle just a little bit, the water barely flows out? But if you crank it open, the water shoots out with force. And what if I squeeze the hose? The water struggles to get through. Electricity works almost exactly like this water. The pressure from the faucet is like voltage. The water moving is the current, and my hand squeezing the hose is resistance. Today, we're going to find out how these three interact in our home circuits. Are you ready? For our initial activity, we'll be unlocking difficulties. Number 1. The push or pressure that move electrons. It is measured in volts. The correct answer is voltage. Second, the actual flow of electrons, measured in amperes. So the answer is current. The opposition to the flow of electrons, it is measured in ohms. Okay, so the answer is resistance. These three are tied together by Ohm's law. That is the voltage, current, and resistance. Let's discover what this law says. For our learning experience, we'll be conducting a simple activity titled The Brightness Investigation, a virtual simulation showing two circuits, one series and one parallel. So we will have two investigations. First is adding batteries. Second, adding loads. For our first investigation, adding batteries. So look at the two images. What do you notice about the brightness of the two circuits? Remember that in the first picture, there's only one battery, and on the second picture, there's two batteries. So, compare the brightness of the two circuits. Which glow brighter? The circuit with only one battery or with two batteries? Correct. The circuit with two batteries glow brighter. And this time, let's look at the two circuits. So the two circuits have two batteries, but the first circuit has only one bulb and the second circuit has two bulbs. Now, compare the brightness of the two circuits. Which glow brighter? The circuit with only one bulb or with two bulbs? Right. The circuit with one bulb glow brighter, while the circuit with two bulbs are dimmer. So for guide questions, number 1, in the series circuit, why did the bulbs get dimmer when we added more loads or bulbs? And for question number 2, if we want to increase the current or symbol I, capital I, in a circuit without changing the bulbs, what should we do to the voltage? Our symbol is capital V. So for answer key number 1, in series, adding loads increases the total resistance, which chokes the flow of current. So meaning, if you add more load, it means that it will add resistance. So adding more resistance means lower current. And for number 2, you should increase the voltage or add more batteries. So from our lesson, we learned about the Ohm's law. It states that current is directly proportional to voltage and inversely proportional to resistance. So to make it easier for you to understand, let's break it down into two parts. Number 1 is direct proportionality. It means that When one value increases, the other also increases. And current and voltage have direct proportionality. Adding more batteries increases the voltage, which increases the current of the circuit. So that is the reason why increasing more battery makes the light or the bulbs brighter. Second, inverse proportionality. Current and resistance. Adding more loads or bulbs, it decreases the current of the circuit. So adding more bulbs to the circuit without adding batteries, you are increasing the resistance. That's why it becomes dimmer as you increase the number of loads. Mathematically, we can express Ohm's law as I equals V over R. I stands for current, V stands for voltage, and R stands for resistance. So you'll just simply divide the voltage and resistance to get the value of the current. Or we have alternative formula, V equals I times R. It means that voltage is equal to the product of current times resistance. So as you can see at the bottom, we have here a triangle. This is what we call the triangle of Ohm's law. If voltage is missing, you just use your finger to cover the V. And what is left at the bottom is I and R beside each other. If they are together, it means that you will multiply them. So to get the voltage, multiply the current and resistance. And using your finger, if current is missing, put your thumb on letter I or the current and you will get V over R. V over R means that you will divide it. You will divide voltage over resistance. And the same way, using your finger, if resistance is missing, you will just cover it and then divide V over I or voltage over current. That is how you use the triangle of Ohm's law. Sample problem. A light bulb is connected to a 12 volts battery. The resistance of the bulb is 4 ohms. How much current flows through the bulb? So the symbol for resistance is ohms. This symbol is actually ohms. And the unit for voltage is capital V. So from our problem, the given values are voltage and resistance. Voltage equals 12 volts. Resistance is 4 ohms. The current is missing. So we will use the formula I equals V over R. So the solution is I equals 12 divided by 4. So to get that, we will just simply divide them. So the correct answer is 3 amperes. Okay, this time it's your turn. A current of 3 amperes flows through a resistor of 5 ohms. What is the voltage across the resistor? So to answer that, first let's write the given. I is equal to 3 ampere and resistance is 5 ohms. Formula V equals I times R. So to get that, 3 times 5 equals 15 volts. The answer is 15 volts. Another problem. A device uses 2 amperes of current when connected to a 10 volt source. What is the resistance of the device? So again, let's write the given values. Voltage equals 10 and resistance is 2 ampere. To get that, we will divide 10 divided by 2. So the correct answer is 5 ohms. Another problem. A light bulb operates at 220 volts and draws 2 amperes of current. What is the resistance of the light bulb? So from the given, the volts is 220 volts and the current is 2 ampere. The formula equals R equals V over I. And to answer that, 220 divided by 2, the resistance is 110 ohms. And now let's wrap up our learnings. Current is the rate of flow of electric charge or electrons through a conductor measured in amperes. Voltage is the pressure that pushes electric charges through a conductor provided by sources like batteries. Resistance is the measure of opposition or friction a material offers to the flow of current. Voltage is measured in volts, current is measured in amperes, and resistance is measured in ohms. They are related by Ohm's law, V equals I times R, where higher resistance decreases current and higher voltage increases current. For ways forward, create a Venn diagram or comparison chart showing the similarities and differences between series circuit and parallel circuits in terms of number of paths per current, effect of adding loads, brightness of bulbs, effect when one bulb is removed, relationship of current, voltage, and resistance. And now grab your pen and your notebooks. It's time for assessment. Number 1. According to Ohm's law, if the voltage across a resistor is tripled while the resistance remains constant, what happens to the current flowing through it? A. The current is tripled. B. Current is reduced to 1/3. C. The current is doubled. Or D. The current remains the same. Number 2. A heater has resistance of 24 ohms. If it is connected to a 120 power supply, how much current flows through the heater? A. 2 amperes. B. 2880 amperes. C. 96 amperes. Or D. 5 amperes. Number 3. If you are measuring the flow of electrons past a specific point in a circuit, which unit of measurement should you use? A. Watts. B. Amperes. C. Volts. Or D. Ohms. Number 4. A student increases the resistance in a simple circuit while keeping the battery voltage constant. What will happen to the current in the circuit? A. The current will reverse direction. B. The current will stay exactly the same. C. The current will decrease. Or D. The current will increase. Number 5. Using the water hose analogy, if the water pressure is the voltage and the water flow is the current, what represents the resistance? A. The amount of water in the source tank. B. A narrow section or a valve partially closed in the hose. C. The speed at which the water hits the ground. Or D. The height of the water tank. Okay, let's check your answers. The correct answer number 1 is letter A. The current is tripled. Correct answer is letter D. 5 amperes. Number 3, the correct answer is B. Amperes. Number 4, the correct answer is letter C. The current will decrease. And number 5, the correct answer is letter B. A narrow section or a bulb partially closed in the hose. How did you do? Did you get a perfect score? See you next lesson. Remember, electricity is all about the balance of power. See you in the next exploration. Thanks for your support. Please like and subscribe to Sir Dom's blog. Goodbye!